Hello everyone, today in this video we are going to talk about properties of electric charges. After this video you should be able to explain the three properties of charges, and the three properties of charges are additivity, quantization and conservation. So the three properties of charges are additive nature, quantization and conservation. So we will explain each nature one by one. So the first is additive nature. So according to additive nature, the total charge of a system is algebraic sum of all the individual charges present in it. So suppose there are n point charges on an object and they are q1, q2, q3, q4 and so on. So the total charge will be the algebraic sum of all the charges. So we just have to add all the charges keeping in mind the sign of the charges. Algebraic sum means we have to consider the sign of the charge. So let's take an example. So this is an object and there are several charges like 1 microcoulomb, minus 5 microcoulomb, like this. So total charge will be, I'll just add all the charges and I'll add all the negative charges, I'll add all the positive charges and I'll subtract them at the end. So the total charge of this object is algebraic sum of all the charges, which will come as positive 4.7 microcoulomb. Now the second property is quantization. Now let's understand the quantization by taking a simple example. Suppose you have a piggy bank and suppose you put only 5 rupee coin on this piggy bank. So when you break your piggy bank, is it possible for you to get 17 rupees? No. Is it possible to get 15 rupees? Yes. What about 111? No. What about 155? Yeah, we can get 155. Can we get 1063? No. Can we get 1055? Yes. So the total money inside this piggy bank should be multiple of 5 because we are only putting 5 rupees. So the amount which is not the multiple of 5 rupees should not be there. So this is the quantization. That means we cannot have any value. So it should be multiple of certain value. So now let's understand the quantization in charge. So charge of an electron is minus 1.6 into 10 to the power minus 19 coulomb, and charge of proton is plus 1.6 into 10 to the power minus 19 coulomb. So you can see they are equal but they are opposite in sign. So we can denote a basic charge by E. That means whatever charge is there in the object, it is either because of electron or because of proton. So we can have only this charge, that is basic charge. So in order to make an atom positively charged, we have to take away one electron, and in order to make it negatively charged, we have to give extra electron. That means the transfer of electron is the cause of charging. So but out here we can see we can transfer either 1 electron, 2 electron, 3 electron, 100 electron or 1000 electron. That means we can transfer only integral number of electron. So we cannot transfer half electron or 1.5 electron. So non-integral number of electron is not possible because we cannot break the electron. So this is the smallest possible charge. So total charge of an object should be the multiple of charge of electron. That means only because of transfer of electron we are getting the charge. So according to quantization, the total charge of a body is integral multiple of basic charge. So that means total charge is integer into basic charge, that is charge of electron or proton. So this is the formula. Q is equal to Ne for quantization, and N is the integer. It is either plus minus 1 or plus minus 2, like this. So what is the cause of quantization then? So as we have already said, we can transfer only integral number of electron. We cannot transfer half electron or any fraction of electron. So we have to transfer integral number of electrons. So that is why the total charge is also integral multiple of charge of electron. So now we will solve one question based on quantization property. So what is the charge of 1 million electrons? So out here number of electrons are given, that is 1 million is 10 to the power 6, and charge of electron we already know, 1.6 into 10 to the power minus 19 coulomb. Now we know Q is equal to Ne. So this is coming from quantization of charge. So now if you put the value, then you will get Q is equal to 1.6 into 10 to the power minus 13 coulomb. And how many electrons make 1 coulomb is the second question. So out here total charge is given, that is 1 coulomb, and charge of electron we already know. Now we know from quantization of charge Q is equal to Ne, so N is equal to Q by E. So now this 19 will go up and become positive, so this will become 10 by 16 if you take this decimal point out here. Now if you divide 10 by 16, you will get 0.625 into 10 to the power 19. So I can shift this point out here, so it will become 6.25 into 10 to the power 18 electrons will make 1 coulomb. Now one more application of quantization of charge. So this question is saying, is a charge of 8.0 into 10 to the power minus 17 coulomb possible? Out here total charge is given, that is 8.1 into 10 to the power minus 17, and we know the charge of electron, we have to find number of electrons, and if this n is integer, this charge is possible. If it is not integer, it is not possible. So let's see. So we know Q is equal to Ne and N is equal to Q by E. So if you put the values, this 19 will go up, and you can write this as 80 by 16 into 10 to the power 2. So it is N is equal to 5 into 10 square, so that is 500. So it is integer, so the charge of 8.0 into 10 to the power minus 17 coulomb is possible because N has came as integer. Now let's try another question. Is a charge of 16 into 10 to the power minus 21 coulomb possible? So I'll solve this problem the same way I've done in the previous one. So let's find N. After putting value, taking this 19 up, and this is 160 by 16, so you'll get 10 into 10 to the power minus 2. So this will be 10 to the power minus 1, that is 0.1, and 0.1 is not an integer. So the charge of 16 into 10 to the power 21 coulomb is not possible. Now let's try one more question. Is a charge of 1 microcoulomb possible? So 1 microcoulomb is very large charge as compared to charge of electron. So if you do the same way, you can find this number to be like this. So it is an integer, it is possible, but the actual charge of electron is this much, 1.60217, like this. So if you do the same question using this value of E, you will get this value and decimal is coming out here, so that means this is not an integer. So according to this charge, it is not possible. So for the same charge of 1 microcoulomb, according to this it is possible, according to this is not possible. So as 1 microcoulomb is very large as compared to this charge, so we ignore the quantization of charge when we deal with large amount of charge. So we say 1 microcoulomb is possible, so we can neglect this property while dealing with large amount of charges. So the next property is conservation of charge. So according to law of conservation of charge, the total charge of an isolated system will remain constant. That means charge can neither be created or nor be destroyed. It can be transferred from one system to another. So we cannot create or destroy charge. You can use one of the definition from here. So now let's take an example of law of conservation. So we know on rubbing a glass rod with a silk cloth, we get positively charged glass rod and negatively charged silk cloth. Before rubbing, both are neutral. So charge on glass rod is 0 and charge on silk cloth is 0. After rubbing, after charging this, we know they get equal and opposite charges. Suppose the charge on glass rod is 1.5 coulomb, then charge on silk cloth will be minus 1.5 coulomb. So before rubbing the total charge is 0, and after rubbing if you add them together you will get 0. So before rubbing is also 0 coulomb and after rubbing is also 0. So in this process we are not creating this positive and negative charge. These charges are already there in the atoms, but we are just transferring electron, making one as positively charged and another as negatively charged, but total charge of the system is same. So when you keep them in contact, the electron will flow to the glass rod, again will get 0 coulomb. So this is the explanation. You can pause and copy. So second example is ionization of salt in aqueous solutions. We know NaCl is the common salt. When we dissolve this in water, it breaks into Na plus and Cl minus. So that means sodium will lose one electron and calcium will get one extra electron. So before dissolving, the charge in NaCl is 0 because it is a neutral, and after dissolving Na loses one electron, that is one positive charge, and chlorine gets one electron, so that means one negative charge. So if you add them together, this will come as 0. So before dissolving it is 0, after dissolving it is also 0. So we are not creating this charge, we are just transferring electrons. So this is same explanation. You can pause and copy. Now next example is fission of uranium nucleus. So when a uranium nucleus is bombarded with one neutron, it breaks into barium and krypton and 3 neutrons. So it happens in this way. So you can see it is one uranium is breaking into 2 small nucleus and 3 neutrons. So now see out here. So total charge before fission is, so this is 92, means number of protons or atomic number. So before fission there is no charge in neutron, so 0e plus 92 protons, so it is 92e. So after fission, so this is 36 protons plus 56 protons plus 3 neutrons, that is 0 charge. So if you add them you will get 92. So before fission is also 92, after fission is also 92. So total charge is conserved in this process also. So next example is pair production. If we have a photon or gamma ray or light of very high energy that can produce one electron and one positron, so this is called pair production. So one photon is giving positively charged positron and electron. So positron is just positive electron. Annihilation is the another process. We take one positron and one electron, and when we combine them it produces 2 gamma ray or 2 photons. So this is the explanation. You can see one photon is producing one electron and one positron, and before pair production total charge is 0 because light has no. After pair production, one electron and one positron. Electron is negative and positron is positive, so you will get 0. So before is also 0, after pair production is also 0, so 0 charge. So the charge is conserved. And in annihilation, one positron and one electron are giving 2 gamma ray. So charge of electron is minus e, charge of positron, that is positive electron, is plus e, so 0. So after annihilation we are getting 2 photons. Photons or light do not have any charge, so before and after charge is 0, so charge is conserved. So let's summarize the video. There are 3 basic properties of charges. One is additive nature, that says total charge of a system is algebraic sum of all the charges present on it, and we can charge an object by adding or removing electrons. So total charge is integral multiple of basic charge, that is charge of electron, and formula is Q is equal to Ne, and the cause of quantization is transfer of integral number of electrons. We cannot transfer half electrons. And the third one is conservation of charge. Total charge of an isolated system is conserved, and some examples are frictional electricity, ionization of salt, fission of uranium, pair production, and annihilation. Now you can try these questions. These are the important questions from these topics. So I think this is the end of the video. I would love to hear your opinion about my video, so please write something in the comment section. Please don't forget to like the video. Yeah, you can like it now. And please subscribe my channel if you are new to this channel, and you can share it to your friends. And out here I'm giving my phone number. If you need help in any topic, you can WhatsApp me. Thank you.